So let's talk about one of the biggest questions in AI today. How do we go from brilliant but kind of clueless AI to one that has actual genuine common sense? We're going to dive into the deep architectural challenges and this massive quest to build something called world models, which might just be the foundation for an AI that can finally truly understand our world. We have all seen the incredible stuff AI can do, right? It can generate videos that look totally real, write poetry, but then you see the other side, the absurd mistakes. You see an AI that thinks a key can be made of cheese or that you can walk through a solid wall. And that's the paradox we're living with. Today's AI is brilliant, but it's also incredibly brittle. It can memorize and repeat, but it doesn't really get it. So, what's actually going on under the hood? Well, one of the biggest problems is a failure mode called representational collapse. It sounds complicated, but the idea is simple. Imagine you're training an AI to tell the difference between 100 different things. The easiest, laziest path for the model is to just give up and decide everything is, well, the same thing. Every single input gets mapped to one single, totally useless output. The whole system just collapses into a single point of ignorance. It's lost all its flavor.
Okay, so here's our game plan. First, we'll dig a little deeper into that flaw in the brilliance. Then we'll explore the hunt for world models. We're going to look at the two main ways people are trying to build them, uncover the secret to keeping them stable, and then see how this all comes together to power an autonomous agent. And finally, we'll talk about why this is so important for building responsible AI.
All right, first up, the flaw in the brilliance. Let's really get to the bottom of why these incredibly powerful systems still don't have a basic grasp on reality. And this right here, this is the end result of that collapse. You can think of a system's ability to hold diverse information as its information entropy. And when a model collapses, that entropy drops to zero, flatline. It becomes a system that basically knows only one thing, which, is the same as knowing nothing at all. So that's the problem, and it leads us to the grand challenge for the whole field, which is this: the quest for world models. The big idea is to build an AI that has its own internal simulator of reality. And what exactly is a world model? Honestly, the best way to think about it is as an AI's own little digital twin of the world running inside its head. It's not just a giant database of facts. It's a dynamic simulation that lets the AI understand how things work, predict what might happen next, and then, and this is key, plan its actions based on those predictions. This is the bedrock of common sense. But how do you actually build one of these? Well, that brings us to a major fork in the road. This is the great debate happening in AI labs right now. Should we teach an AI to generate the world in picture-perfect detail, or should we teach it to just predict the underlying rules? So on one side, you have the generative models. Think Sora or GPT. Their main goal is fidelity. They're trying to predict every single pixel, every single word, to make a perfect copy of reality. But on the other side, you've got predictive models, like Meta's JEPA architecture. Their goal isn't fidelity, it's plausibility. They don't care about the pixels, they just want to predict abstract ideas about the world to understand its rules. And as AI pioneer Yann LeCun says, forcing a model to predict every last detail is just a dead end. And why is that? Because the real world is messy and unpredictable. Think about it. There are a million different ways a glass could shatter if you drop it. Forcing an AI to predict just one of those outcomes perfectly is not just a huge waste of energy, it's pretty much impossible. Okay, so if prediction is the way to go, how do we make sure our predictive model is stable? This brings us to the secret sauce. How do we stop an AI from doing that collapse thing we talked about earlier and becoming totally useless? The question really boils down to this: how do you force a system to learn rich, diverse, and useful stuff instead of just defaulting to the laziest, simplest answer it can find? Well, one really clever solution is a method called VICReg. You can think of it as a set of 3 mathematical forces that work together to keep the AI honest. First, you've got invariance. This rule basically says, hey, this is the same object, even if I'm looking at it from a different angle. It pulls representations of the same thing closer together. Then you have variance. This is the anti-collapse force. It pushes all the different representations apart, making sure they don't all clump into one useless blob. And finally, there's covariance. This one says, don't be redundant. It forces the AI to learn distinct features, maximizing the amount of useful information it can store. And this quote just nails it. It's a perfect metaphor. A system without distinctiveness, without that variance we just talked about, is like salt that's lost its taste. It's lost the very thing that makes it useful.
It's just there. A uniform, useless substance, just like a collapsed AI.
So now we have the key to stable learning. Let's see how this all gets put together to build an AI that can actually do things in the world. This is the ultimate test, creating a model that can reason and plan on its own. So, one of the proposed architectures for this is called HEJPA, which is basically a hierarchy of thought. At the very top, you have a semantic layer. This is like the CEO, handling high-level strategy. Plan a trip from New York to Boston. Below that, a tactical layer acts like a manager, dealing with intermediate plans like, okay, find the next highway exit. And at the bottom, the detail layer is the frontline worker, handling immediate actions like steer now to avoid that car. And this isn't just theory, it maps perfectly to a super complex task like a self-driving car. The big picture, city-to-city strategic planning, that's handled by the top semantic layer. The moment-to-moment dynamic obstacle avoidance, that's the job of the low-level prediction layer. And juggling all the different rules, traffic laws, passenger comfort, battery life, that's managed by a special model that understands what's possible and what's not. Okay, this all brings us to our final and maybe most important section. Why does any of this technical stuff actually matter? Well, it's all about connecting these design choices to the urgent need for responsible and ethical AI. The reality is, the world is catching up. New rules and regulations are starting to pop up, and they're demanding that AI systems do more than just spit back data. They need to understand context and, crucially, predict consequences. This capability has a name: consequence mapping. It's the AI's ability to simulate what might happen because of its actions. And this is not just some nice feature to have, it is an absolute prerequisite for human accountability. How can we hold a person responsible for an AI's decision if the AI itself couldn't even provide a basic risk assessment? And here's where it all comes full circle. The very architecture we've been talking about gives us a path to this kind of responsibility. The joint embedding part provides contextual understanding. The predictor part is what enables consequence prediction. And another special variable allows the model to explore a whole range of possible futures, which lets it do proactive risk assessment. The ethics are literally built into the engineering. So if there's one thing to take away from all this, it's that building responsible AI isn't just about writing a list of ethics rules and tacking them on at the end. It is about the architecture itself. When you build predictive models that learn the fundamental rules of the world, you create a foundation of common sense, and understanding consequences becomes a natural built-in part of the system. This is the engineering path to AI we can actually trust. But this all leaves us with a really deep question. If an AI can reliably predict what will happen because of its actions, does that actually make it responsible? Or does it just make us, the people who build and use it, more responsible than ever for how we decide to wield that power?